Good morning, everyone. Today our topic is Introduction to Slides. So let us understand the basic concepts of sets in mathematics in this slide. So, what is a set? We can define a set as a set is a collection of well-defined and distinct objects or elements. For example, we can take a set A is equals to 1, 2, 3, 4, 5. So these are the collection of well-defined distinct objects or elements we can say. And coming to the set B is equals to A, B, apple, banana and mango. So these three are also distinct objects or elements, and the sets should be defined in the curly braces only. So this is a set. Coming to the next slide, we have the types of sets. They are finite set and infinite set. Coming to finite set has a definite number of elements, which means we have some finite number of elements or definite number of elements. For example, set A is equals to 2, 4, 6, 8, 10. So here the set has only 5 elements. It means it's finite. So this is a finite set. And coming to the infinite set, an infinite set has an endless number of elements, which we can say it has an infinity number of elements. So coming to the example, we have that B set equals to 1, 2, 3 and 4, 5. The set of natural numbers, which means infinite. We have so many natural numbers which we cannot define. So there are infinite number of elements we have in natural numbers. So it is an infinite set. Coming to next one, representation of sets. We can represent the set in two ways. That is tabulation, roster method, or rule set builder method. Coming to the tabulation method, it can be defined as listing all the elements of a set separated by commas and enclosed in braces. For example, C equals to 1, 2, 3, 4 and 5. So these are listed explicitly, which means these are listed by us directly in the set. So coming to the rule method, describes the properties of elements rather than listing them. We doesn't define the elements explicitly, but we define something like a properties of that element. So by looking at the properties of that set, we can get the we can list the elements. So coming to the example, C equals to x belongs to x is a natural number less than 6. So we can read it as C is a set of x such that x is a natural number less than 6. So here we can define set C equals to 1, 2, 3, 4, 5 because it is less than 6. So coming to the next slide, uh, we have null set. Null set and equal sets are types of sets. So the null set means a null set or empty set has no elements. A set which doesn't have any elements is known as null set. For example, here D set is a x belongs to x such that x is a prime number between 8 and 10. So here no such number exists. So D equals to null. So D is equals to null set. So next coming to the equal sets. It can be defined as two sets are equal if they contain exactly the same elements. For example, we have set E is equals to 1, 2, 3 and set F is equals to 3, 1, 2. So they have the same elements. So we can say that they are equal elements. So E equals to F, order doesn't matter. Now coming to the subset and power set. Definition of subset is a set A is a subset of B if every element of A is also an element of B. For example, we have set A is equals to 1, 2 and B is equals to 1, 2, 3, 4. So we have elements in A are present in set B. So we can say that A is a subset of B. So coming to the power set, a power set of set A is the set of all possible subsets of A. So here if A is equals to 1 comma 2, then power set of A equals to null set. Null set comes under the subset of the set. So null set and 1 set and 2 number set and 1 comma 2 number set. So this is a power set of set A. Now power set has 2 power n subsets. Here n is equals to 2. So we have 4 subsets. So coming to the next slide, we have universal set. We can define the universal set as universal set contains all possible elements under consideration. For example, if studying natural numbers below 10, we can say that universal set is equals to 1, 2, 3, 4, 5, 6, 7, 8 and 9. So this is a universal set. So this is about my presentation. Thank you for listening.